Welcome to another session of INF 164. In this session we are going to continue with classes. So the prerequisite for this video is the previous video, because we are going to use that rectangle class we created previously to explain certain concepts. So from the previous video we dealt with this rectangle class. It has these private attributes which is your m length and m width. It has these properties, which is your length and your width. So again, in the previous video we explained how these properties work. When you have private attributes or members, you must have properties. So we also observed that we have two constructors. We can create objects using this default constructor, which will initialize the length and width to zeros, and we had this overloaded constructor which will initialize your length and width to specific values that the user chooses. So we also did array of objects. For example, for the rectangle class, if we wanted to create an array of objects, we were supposed to say, let me do this, we were supposed to put the type, which is a rectangle, then we specify that it's a 1D array, then we specify the name. Maybe this is the array is equals to new, then you specify rectangle, then you specify the size. For example, 3. We know that this will create an array in memory of size 3, where you have 3 memory locations. So you have 0, then you have 1, you have 2. We know that by default for objects they are initialized to null. So they are initialized to null. So to populate this array with rectangle objects, what you can do is that you can define a rectangle object. This is the first approach. You can say rectangle, then r maybe equals to new, then you can say rectangle. You can either use the default constructor or overloaded constructor. Let me use this 2 by 3, right? Then you can say array at 0 is equals to r. So how is this going to work? So we know that this line of code only, it's going to create a new rectangle object called r. So r has a length and width. We are using the properties width. So the length is 2, the width is what? It's 3. So it's very important to remember what we did in the previous video to understand this. We covered this in detail in the previous video. So if you forgot, you must go back and refresh. So we have this r having a length and width of 2 by 3. Then now we are storing this r at position 0 of our array. So this array will point, it's still pointing to 3 memory locations, 1, 2, 3. So 0, 1, 2. These ones are still null. This one is still null. Then here we said is equals to r. This means it's going to store this specific rectangle. So it's going to store this specific rectangle object at position 0, because we said array 0 equals to r. So here it's going to store this rectangle having a length and width. So it has a length of 2 and a width of 3. This is what we did in the previous video, even though we didn't do it step by step. An alternative approach, instead of doing it step by step, defining an object, then assigning that object. An alternative approach will be to use the array directly. So you can say array at position, for example 1 is equals to new, then I specify rectangle, then I'm going to specify the dimensions. I can use the default constructor or the overloaded constructor, so 3 by 6 for example. So it's going to go to position 1 in the array. So position 1, it's this one, it's this one. So it's going to create a new rectangle having dimensions 3 by 6. So we have a length of 3 and we have a width of 6. So it's going to create that array or that rectangle in that specific position. This is another approach. So you can do it using this approach, which is to just call, you use the new keyword and whatever constructor, or you can do it step by step. Step by step, you first create a single object of the rectangle class, then after that you store that object inside whatever position you want. Later we can change R to something. Remember, R is a variable, so it can change. Later we can say R is equals to new rectangle, then maybe 5 by 10. So R was storing this one, so R was storing this. So later when we say R is equals to something else, it's going to avoid this, like the way variables work. It's going to store this new rectangle having dimensions length, which is 5, and width, which is 10. So at the end, my new R is this one. Then after doing my new R, I can say array at 2 is equals to R. So at position 2, so position 2, it's here. So let me do this just to extend. So at position 2, it's going to store the new R, which is length, so which is 5, and width, which is 10. Like that. So that's the idea behind working with arrays. So that's how you can store elements, or that's how you can create an array of objects. The first alternative is to do it the straightforward approach. You create the object, you store that object at whatever position you want. The second approach will be to do it directly by using the new keyword and the constructor. This line creates a new rectangle. Then we are storing it at position 1. So those are the two ways you can like populate an array of objects. So let's say we had an array, maybe let me say array of objects, maybe let's just make it of size 3, so 0 1 2, maybe an array of rectangles where we have this. So we have length, width, then we are going to have this, then we have the length, then we have the width, like this. Then again at this position we have the length and we have the width. So we have something like this. So let's say it's a 2 by 4 3 by 6, maybe 1 by 5. So in the previous video we saw how to loop through this array. You can use a for loop or a for each loop. Then how do we actually change things? So if I say array at 0 dot length, what am I referring to? Array at 0, it's this, so it's referring to this specific rectangle. That if I say dot length, it's going to return 2. If I'm reading, it's when I'm not using equals to. When I'm using equals to something, maybe 4, equals to will change the value. So this 2 will be changed to 4. So again, if I say array maybe 2, then I say dot width is equals to maybe 7, it's going to go to position 2. Then position 2, it refers to the specific rectangle, so it's going to change the width to 7. So this is going to change to 7. Then again I can say maybe array 0 dot get area. So from the previous video we saw that the get area method returns the area, which is the length times width. So let's see, so length times width, so here it refers to position 0, so this is going to return position 0. We have 4 by 4 because we changed, so 4 times 4 is what? It's 16. It's going to return 16. So you can access like the length, width, whatever, get area, get perimeter of each rectangle objects using the array indices. So everything seems fine with an array, but what are the disadvantages of an array? So disadvantages. So an array is fixed, so the size is fixed. So once you create an array, for example, of 3 items, this size cannot increase. To add items to this array, you have to to add items to this array. Let's say you have an array of size let's say 2, for example, 0, 1, then it's pointing to certain rectangles, R1, R2, something like that. So to add another rectangle to this array, you have to create a new array having a size of this size plus 1. Then after doing that, you have to copy the first array, R2. Then after that, you can successfully add another rectangle object. So it's not easy, so it's fixed, so it's not easy to add or remove items. Even for removing, let's say you wanted to remove R2. To remove R2, okay, you delete R2, right? But after deleting R2, you are going to have this R1, then you have what? R3. Here you have a space. After this, you have to make a new array that is one size less than the original one. Then you have to copy this R1 and R3. You can see that writing the code for this is very complicated. So an array, it's fixed, it's not dynamic, and adding or removing elements in an array is not an easy task. It's possible, but it's not easy. Instead, we are going to introduce something that will make our lives easier. So we are going to introduce what we call a list. So a list, it's So it's a special type of array. So a list allows you to add or remove items. Then the other property of a list is that it can grow. So it can grow or it can shrink. Then for other properties, you can look at your lecture slides. They explain in detail, but for me, I'm not here to just explain the theory. I want you to understand how to code these things. So those are the properties of a list. Then what about the syntax? So the syntax for creating lists is that you just say list, open bracket, you specify the type, then you specify the name, then you say equals to new, then you say list, then you specify the type, then you close, then you open brackets. So notice that type can be anything. It can be an integer, it can be a double, it can be your own defined type, for example rectangle. It can be any type that let's say you created a class for students. It can be any of those. It can be anything, like any valid type, whether it's a C# type or a type that you created yourself. So let's look at an example. How can we create a list of rectangles? So let's see. So you are going to say list, then you specify the type. In our case, the type was a rectangle. Then you specify the name. Maybe for example, I can say array, whatever, equals to new. Then you specify list, open bracket. The type is still rectangle. So rectangle. Then you just open and close. So let's see how is this represented in memory. So this is an array, it's an empty list. By default, this is an empty list. So it's empty like this by default. So you have your empty list. When this line of code creates an empty list of what? Of rectangles. The name is what? It's array. Even it's just ARR. Then the question is, how do we then add items to the list? So the general syntax is there are two approaches like similar to arrays. So first approach is that one of step by step. So you create an object, then you add the object to the list. So the first approach is to create an object, then you add the object to the list. The second approach is to add using, so you add an object using a constructor. So it will make sense now. So let's say we wanted to add something to our list. So we are going to say, let's do the step-by-step approach where you create an object. You create a rectangle object, rectangle r equals to new. You can use a default constructor. For example, if you use the default constructor, you just say like this. Then after you say r.length equals to maybe 5. Then you say r dot width equals to 10. We know that after we executed these lines of code, we are going to have R, which is a rectangle which has a length and a width of what? 5 by 10. So we have a 5 by 10 rectangle object. So this is step 1, is to create your, so this is your step 1 of adding. So you first create a new rectangle object, then step 2 is to add the rectangle object. So this is step 2. So we just say the name of your list. So in general, you just say list whatever name dot add, then you specify whatever object you are adding. So this is the general case. So in this case we wanted to add this R, the newly created object. So we are the name of the list is what? It's ARR. So we are going to say dot add. Then what are we adding? We are adding the newly created R. So as easy as that. So this is step 2. So step 1 was to create the object. Then after creating the object, you add the object to your list. So how will this work? Remember, initially we had an empty list. So this is empty, the size is 0. Then this list will increase, the size will increase by 1. So this list is going to be like this. So it's going to be extended. It's going to be array. Then you have position 0. It's going to be an array of size 1, sort of. Then at position 1, what are we going to store? We are going to store this newly, because we added the rectangle object, we are going to store this. So we are going to store this, a 5 by 10 rectangle. So we are going to have a rectangle 5 by 10 where length is 5, then width it's what? It's 10. So it's going to be like that. So it's going to be like this. So we have a 5 by 10 rectangle. We successfully added the rectangle. Then another approach. So after this, after executing the add, our list it's expanded. It's of size 1. Then it has only one rectangle. Then let's say next iteration, or we want to add another object. So we can do it again step by step, similar to this approach, or you can do it using the shortcut method. It doesn't matter. So with the shortcut method, I'm going to say, okay, let's add directly array dot add. Then I'm going to specify the object. I'm going to create a new rectangle object in memory. Then I'm going to specify the dimensions 2 by 6 like this. So if you do it directly, you are going to use, normally you use the overloaded constructor if you do it directly. So you just do it like that. We know that this line of code will create a new rectangle object in memory. So how is this going to work? Let me copy the array. Then and paste it here. Then let me go back to the pen. So this line of code, every time we say add, we are going to increase the size. It's going to increase automatically by 1. Then what are we adding? We are adding a new rectangle. We know that new rectangle is going to create a rectangle object having dimensions, length, in this case it's 2, then we have width, which is what? Which is 6. So we are going to add this newly created rectangle to our list, or to our, in this case it's just a list. So a list is the same thing as an array, but the advantage of a list is that you can add items. It grows as you add items. So I can provide other examples just for this to sink in. So let's say I'm using the shortcut method r.add. Maybe I can say new rectangle. Then we say maybe 7 by 8. So we know that this will increase the size. Also the indices 0, 1. So 7 by 8 will increase the size of my list by 1. So we are going to have position 2. Then it's going to add a newly created rectangle. So it's going to add rectangle having these dimensions. So length, which is 2. In this case it's 7. So we have 7, and it has width, which is 8. So as easy as that. So at the end you have a normal array. You can use a for loop, you can use a for each loop again to iterate through this array. Then let me copy the array or the list. It's a list actually, but it's the same thing. The difference is that this one can grow. Let me do this. So I want to copy it doesn't want to allow me to go. Nah, it doesn't. Oh, I can zoom out. Actually, I forgot that I can zoom in, I can zoom out. So let's copy this. So we are going to select the array. Then I'm going to paste it here. Then I'm going to select my pen back. Then let's see. So now how do we actually remove items? We saw how to add items, removing items. So you can just say the list name dot remove, then you say add, then you specify the index. So as easy as that, you don't have to do complicated things. So this is the name of your list. This is just remove, add, then this is the position. For example, if you wanted to remove this rectangle, you just say r dot remove, then you say add, then you specify the position. In this case it's at position 1, so it's going to say at 1. So after this line of code, the size will shrink again. So if I try to do this, so I'm going to have my array here pointing to that. but the size will decrease because I removed that. So I'm going to have 0, 1, then at position 1 it will be removed, so this one will be removed. Then I'm going to remain with this length, width, so I'm only going to remain with 2 rectangles. Then I have this other one, length and width, which is 8, then 7. So that's the idea of removing, as easy as that. So that's the advantage of this list. Then the last thing that you have to consider before going to real examples is the binding list, or actually even looping through. Let me check something. So this just want to see if I'm not missing anything. So we did arrays, then lists. So yeah, this was just, we did adding, then we have a binding list. So now we are going to consider the binding list, which is a special type of a list. It's a list but with more capabilities, but it works the same way as the actual list. So let's see the properties of a binding list real quickly. It works the same way as the normal list. So a binding list, so it's just a list. So it's a list that affects the data grid view when the list is updated. So this means when we update the data grid view, when we update the list, maybe when we add items and remove items from a data grid view, the list will automatically, the data grid view will automatically be updated. Then it works the same as the normal list. You just say binding list, these brackets, you specify the type. So this is the type. Then you specify the name equals to new. Here you just say binding list. Then this is your type. Then you just do that. So this list is only used to update the data grid view. Adding, it's the same as the normal list. Deleting, it's the same as the normal list. I wanted something. Let me just go to Google. So looking through, this is the thing that I wanted. I wanted how to get the size of a list. So it's .count. So another thing, let me just, now I forgot the default size. Okay, I think this is, so we know that for array, to get the size, you just say array.length. it returns the number of elements in the array. For list, it's whatever name dot count. Even for binding list, you just say whatever name dot count. So that's the difference. But to loop through these, any of this, it's the same code. You just say for. You can use the for each loop or the for loop. It works the same. If you use the for loop, int I equals to 0, I must be less than. You can choose add. If you are looping through the array, we know that it's r.length. If you are looping through this one, it's dot count. For example, name dot count. Then I++. So it works the same way. Then you do something. Or you can use the for each loop, but they work the same. This is just then, like at the end, the list it's an array with special capabilities. They work the same. So now let's go to a real example, like a real coding example. Okay, close solution. So this example is very important. Very, very, very important. To understand the multi-form application with classes, you have to understand this example first, I guess. So let's see the time. Hopefully we are on time. Yeah, it's not that much, but yeah. So I'm going to create a maybe class management, for example. Then for my class management system, so I have to model a real life class, or like maybe for example grade 12, whatever, like grade, or let me say university students. Okay, let's model like sort of university students. So let's say with these university students we have things. Let's say a student, let's say they have a name, they have a student number, they have a date of birth, then they have a GPA, then yeah, let's make it simple like that. Then they can have, let me see, students, I don't want to, like for simplicity, let's keep it like this. Then they can have a method to print their details. So we want a method to print. So how can we model this? We can model this using what? Classes. So these ones, name, student number, date of birth, GPA, they are going to be your attributes. This is going to be your method. So this is the description of the student class. So again, I'm going to go here. How do we add classes? You go to project, then you add class. Then in this case we want student, so here we are just going to say student like that. So we change this internal to what? To public. So we are going to say public. Then we know the general form. You must have your properties, your attributes, which are private. Then for each private attribute, you must have what? Properties. Then you must have your constructors. Then you must have your what? Your methods or your functions. So in this case, you want to model a student. So in this case, you see that a student has a name. Name is a string. Student number, we can model it as a string. Date of birth, it's a new thing that we are going to study today. GPA, we can say double. So I'm going to have how many? 4 private attributes. So I'm going to have private string. So I'm going to say M name, then private string M student number, then private string. Okay, let's start with the easiest ones. So for date of birth, you have to use the date time data type. So you must use the date time data type. You see here they are explaining represents an instant in time, typically expressed as a date and time of the day. We'll see how it works. So you just say the data type of date time. If you want the date and time, you have to use the date time object. So you just say M date time. So that's, in this case we just say date of birth. So date of birth, I'm going to say DOB, short for date of birth. The next attribute is the GPA, so double MGPA. So we have, you see how easy it is to describe this this thing. You have the name, which is represented by a string, student number, which is represented by a string. We are describing a student class, or we are describing a student object in general. It's just a description. So we are describing the date of birth, but to describe date of birth, we have to use a special data type, which is the date time. Then we have to describe the GPA, which is a double. So that's how easy it is to describe those things. Then for every private attribute, we must have a property. As an example, for this M name, you are just going to say public. That's how you create your property. Then what's the data type of this attribute? It's string. Then you remove the M, so you just say what? Name. Then you open, then you say enter. Then what are you going to put? You are going to put your 2 methods. You have the set and get. So the set is used to change the value of this private thing. So you just say M name is equals to value. So this one is used to change this private attribute. Then the get is used to return this private attribute. So we are going to say return M name. Then I close this. Then I repeat. Let me close. I have to close first. Then I repeat the procedure for these ones. If you want, you can pause the video and do it as an exercise. So public, the data type is string. So I'm going to say string. Then I remove the M. So I'm just going to say what? Student number. Then I open, enter. Then I can do the set. Then I can do the get, like that. As easy as that. Next thing that I have to model is what? Is the date of birth. Again, we say public. What is the data type of date of birth? We said it's date time. So I'm going to say, okay, public date time, the data type. Then I remove the M. I'm left with what? DOB. then enter. Again, I just say set mdob equals to value. Then I'm going to say get. We are going to return mdob. So notice that we are just using the private things here, but we just change it. Then the next thing that we need is the GPA. So I'm going to say public. The GPA is double, so we remove the M, we are left with what? With GPA. Then we are going to set M GPA equals to value. Then we are going to get, which is return M GPA. So as easy as that. So that's how we created our properties. Then before I go to the constructors and stuff, how do we represent this as an object? So as an object, we don't care about the private attributes, we care about properties. So the actual representation will be the name of the class, so the description. So we are going to have the name of the class, which is student. Then we are going to have the properties. So what are the properties? We have the name. So a student must have a name. Then the next property is what? The next property is student number. Then this is what? Student number. Then the next property is what? Date of birth, which is DOB. So date of birth, which is DOB. Next property is what? It's GPA. So we have your GPA. So this is your GPA. So this is just a description. I don't know, those of you who are doing database, you know, these are entity diagrams, but in programming we call them UMLs. This is an UML. Because they are public, you just put plus, something like this. If you go to Google and check UML diagrams, then you go to images, then you'll see that if you are doing database, this is similar to what they call their entity things. Let me just go to clear pictures. I don't know if it's INF 171, but yeah, it's something like that. It's INF 171 when they do these UML diagrams, but them they call them another name, which is entity diagrams. This one doesn't actually show. Let's see this one. So let's close this. You see how they represent the UML diagrams. You can see that this on its own, it's a class. The name is student. A student has a name, address, phone number, student number. This is a different like description. Then here you have methods: determine if eligible to enroll in a varsity, provide a list of what. You can see that these are just the same. So these are just UML diagrams. So that was the idea. So this is the description of a student using the properties. Then the next thing that we need is what? It's constructors. So in this case, we set a constructor, you say public, then the name of the class in this case is student. Then let's start with the default one. The default one doesn't receive anything, so we are going to set these things to 0. We can either use these private attributes, or we can use the properties, because we are inside this class, so we can access private attributes directly. So you can say m name equals to empty, like empty string, or if you don't want to use this, you can just use the property name equals to empty. Doesn't matter here since we are inside this class. Then I will repeat the same process. Student number equals to empty. Then date of birth. Normally for date of birth, I prefer to say datetime.now. Datetime.now will return the current date. So if it was this one, it was going to say 23 August 2023 1544. So yeah, it was going to return that specific date. If you want, you can say, if you don't want to be specific, you can set it to nothing, which is null. I guess. Let me see, does it work with null? It's an object, so it's a struct, so it won't work. So this means for this one, you just say datetime dot now. That's how you initialize it. Then the next thing that you have to initialize is the GPA. You can just say equals to 0.00. Then you are done. Then the next thing that you must have is your, this is optional, parameterized constructor. So this constructor must receive the name, student number, date of birth, and GPA, and create a student based on those details. So it receives the name, string name, then it receives, again, if you forgot how methods work, you have to refer to the methods section. Then string, student number, then you need the date of birth, which is data. The data type is datetime, maybe DOB. Then the other thing that you need is what? It's the GPA. So double GPA. So let me zoom out. So yeah, this is my method. So here I'm going to initialize my name. Instead of empty what I'm going to initialize on whatever values I have. So name will be initialized to this name that I received from my method. Student number will be initialized to this student number. Then date of birth, DOB, will be initialized to this DOB that I received. Then GPA will be initialized to this GPA I received. So you have to understand the working of this. Then we are almost done with our class. The next thing that we have to create is the method. So we are done with the constructors. We can create a method. So in this case, we want a method that will print. So we just say public. Since it's only printing, we can say void. Or let's say it returns the output as a string output, or print. So it doesn't have to receive anything because it's going to use these values. So we are going to say string result equals to maybe name plus a new line. Then we say result plus equals to, we are just printing those things. Remember, this is a description. It's a description. We are just describing. Then we are going to say student number. Then we are going to student number, then we add a new line. Then we want to print the date of birth. Then here you can just say DOB, then new line. Then the next thing that we want to print is the GPA. Then we want to add GPA, yeah. Then we are done. We have to return the result. So I did nothing fancy here. Here it's back to INF154 methods. I'm just using those variables. I'm using the attributes, in fact. So yeah, we are done with creating the class. So this was the first step. Now in our form, so the easy part is done. Then in our form, we want to create a data grid view. Like this. So this data grid view will contain our students. So this data grid view must be empty. That's the nice thing about classes. The data grid view is just empty. Don't worry about adding columns and stuff. Then we are going to add a group box. Actually, let's not add a group box. Let's just add text box. So for the name, then copy this, paste for the student number, then paste for the let's be using numeric up down, in fact. Numeric up down, then we are going to paste that. Then what about the date of birth? Then we have this control for date of birth. We call it a date time picker. So this is a new control that you must get used to. So I'm going to add this picker, this date time picker. That's where the user can enter the name and stuff. So let me run this. So you see the user can select whatever year they want. Let me see what's the shortcut. Yeah, they can select maybe 2000, whatever. Then from this they can choose whatever month they want from 2000. Then they can choose, like the user can choose the date on this date time picker. Then we need labels also. Then copy and paste. So I'm going to paste. Let me just copy this. So I'm going to put them like this, just to have a space between. Yeah, I guess this will work. So now let me name them. So here the user will enter the name. Then here they will enter the student. Actually, I'm changing the wrong things, so I'm supposed to change the text. So here they will enter the name, student number, then we need date of birth, then we need the GPA. Then we need some buttons here. Actually, button for adding, button for removing, so copy, paste, paste. Let me just do that. So we have the add, then we have the remove, then we have the edit. Let me paste the edit. So this one, it's btn add. Now we can change the names. So we have btn add, then we have btn remove, btn remove, then we have btn edit. So this is btn edit. Then we have txt name, then we have txt student number, then date time picker, you can say DTP, then date of birth, DOB, something like that. Then numeric up down, it's NUD, in this case it's GPA. So we are done with creating the form. So let me explain the purpose of each thing. So with this kind of setup, we want a system that will allow us to add students. So when we click add student, the student will be added to our system. When we say remove student, the student will be removed. Edit will edit the details of a student. So how can we achieve that? So to store, since we want like multiple students, and we want the system to allow students to be added to the system, we must have a list. We can use a normal list or a binding list, but we want the data grid view to be updated so automatically, so we can use a binding list. Or first, let's use the list. So the first thing that I need is a public variable. It's a global variable, so I need a list of what? Of students. So I can name it students, then equals to new list. Then here I'm going to say what? Student, because the type is what? Is student. So we know that there's in memory, that line of code, it's going to create a list where you have students pointing to an empty list like this. So the list is empty. This line of code, we make it a public variable. That's the first step. So you make it a not public, necessarily public, but you make it a global variable. So you make your list a global variable. So you create a list. This is just an empty list. Then after creating a list, you have to link the data grid view with what? With your form. So with your list. So on form load, I'm going to link the data grid view with the form. So linking the data grid view with the list. So I'm going to, we know the syntax, specify the name of the data grid view, then you say dot data source is equals to data source. It can be a list, it can be an array, it can be a binding list. So let's say students, right? Let's see when you execute this what's going to happen. Okay, let me see, where did I make mistakes? This code is giving me unnecessary errors because it's not even showing me. No. Okay, let me try to analyze the code because I'm getting unnecessary errors. So student list equals to new list, student open close form load dvg students data source equals to students. I don't know if my code is crazy or what, because there are no errors. Okay, let me do this. I'm going to go to this documents 164. Then this one was class management. Then let's go to the bin folder, debug. Then let's delete here. Actually, should I? Yeah. Okay, let's try to run. So this thing is giving me unnecessary errors, which I don't understand. So we have form load. Let me double click on form 1 again. There were built-in errors. Let's say yes and see. Okay. Let's close and open. Then I'm going to open Visual Studio. Also, let me check on device manager if there's something. Actually, it's this. Maybe there's something that is opened that was not closed. Okay, let's run again. This is not good. Because there are no errors, so that's the thing. Let me go to student class. No issues found. Because restarting my PC is not an option while I'm recording. let's see. Okay, let's go down. Because there's no background application that is working. Okay, let's see if this, let me comment out those two, then let me comment out this. Let's execute this. Okay, I guess we'll continue this example in the next video because I don't know what happened. But yeah, we'll just continue this in the next video.